Embedding, the major aim is to form a tissue block. So the embedding station has different components or parts that help us to perform the whole embedding process. So we can call it embedding, blocking, or casting. So number one, it has a compartment for embedding molds. Let's touch there, the surface. Each, okay, these are metallic embedding molds. So this compartment is kept warm, okay? Why? We want free flowing of wax and prevent formation of air bubbles when we are putting in wax in the embedding mold. Okay, so this is our metallic embedding mold of different sizes. Then number two, we have a tissue cassette compartment. Okay, so this is the compartment where we place our tissue cassettes with samples from the tissue processor. Touch. Let's have a feel. Okay, so you realize that it is also warm. When you remove your hands, paraffin wax solidifies immediately. Are we there? So since these samples are coming from the processor, we said the last agent was what? Paraffin wax. Okay, so we still put it in this chamber which is warm. Okay, number one, to ensure that the remnants of paraffin wax are removed, but most importantly to keep it warm, to prevent the tissue from becoming brittle when you leave it to open environment. And number three, we have wax tank or wax reserve. So that's where we put our paraffin wax. Okay, of course in solid form. This paraffin wax pellet in solid form. So when we pour in, it will melt. The other important part is the warm surface. Let's touch here, the warm surface. This surface is warm to ensure that we keep the paraffin wax in molten state or liquid state. Okay, if it was cold, it would have solidified. So we won't be able to put the tissue into the paraffin. In other words, the first steps of embedding paraffin wax is in molten state, and the last stages it is in solid state because it's going to solidify. Then we have the lighting system, illuminated working system. So you have tissues that are very tiny that requires proper observation, and it is accompanied with magnifying lens. So we have smaller pieces of tissue, for example endoscopic biopsies, needle biopsies, and occuratings. They are very small. This one will help magnify, okay, increase the size so that we can carry out tissue orientation. We have a forceps compartment. Let's touch. Still it is what? It is warm. Why? We want to ensure that there is no solidification on the forceps we are going to use during embedding. Then we have paraffin wax dispenser or paraffin wax dispenser nozzle. So this nozzle is connected to the wax tank, okay, for continuous supply of paraffin wax into the embedding molds. And lastly, two cold spots. Number one, small cold spot, and number two, we have the large cold spot. Okay, so this small cold spot is where we carry out orientation majorly. Orientation is proper placing of tissue into the mold. So once you put paraffin wax, you've added your tissue, you carry the whole pack onto this small cold plate to carry out orientation. So different tissues are oriented differently. And orientation is the most important step during embedding, because once you mess up with the orientation, it will affect the results from microtomy, then examination. So we orient basically to position the tissue properly in the mold, either in the middle, diagonally, depending on the tissue you are handling. So how is orientation important? So let's look at these two blocks. This first one, the tissue is in the middle very well. However, the second block, there is an extension. Are we seeing? From the surface. Are we there? So either the tissue was bigger than the mold. Now during microtomy, where is the danger? We are going to cut from the surface, for example. Let's assume this was going beyond. It means this part will be left out. And it could be the part which is diagnostically important. So you're going to cause misdiagnosis of the patient. Then the large cold spot. After completely filling our mold, we carry to the large cold spot, okay, for complete solidification of paraffin wax, so that we can separate the tissue block from the embedding mold to come up with a tissue block.